In this example, we're looking to find the equation of a tangent plane to this surface at this given point. This is the tangent plane equation that we're going to use, and this tangent plane's equation requires the first partial derivatives with respect to x and y. So that's where we'll begin. Let's change our z value to functional notation, and then we'll take the first partial with respect to x, which is going to hold the y value constant. If this y value is constant, then we're simply going to use that constant multiple times e to the x. The derivative of e to the x is e to the x multiplied by whatever the constant is in front. And then we also have the first partial with respect to y, which is going to hold x constant. And so we have that constant multiple e to the x times the derivative of y squared, which is 2y. So when we're looking to find that tangent plane at a given point, we're going to use this ordered triple as the x naught, y naught, z naught values, and 0, 3 are the x naught, y naught values that get plugged into these partial derivative functions. So let's evaluate our first partial with respect to x at 0, 3. So we plug in 0 for all the x's and 3 for all the y's. So plugging in 3 for y, we're going to get y squared, plug 3 in for that, times e to the x, plug 0 in for x. E to the 0 is 1, 3 squared is 9, and so this is going to just be equal to 9. The first partial with respect to y evaluated at 0, 3. Again, we plug in 0 for x, 3 for y. 0 plugged in for x, we're going to get e to the 0. 3 plugged in for y, we're going to get 2 times 3, which is 6. And so this multiplies together to just give me 6. So now we take the values 9 and 6 and we plug them in for these first partials here. And again, z naught is going to be the z coordinate of our ordered triple. So our tangent plane equation becomes z minus z naught is 9 equals that first partial with respect to x turned out to be 9. That's going to be multiplied by x minus x naught is 0 plus 6 is the first partial with respect to y times y minus y naught, and y naught was 3, the y value of our ordered triple. And so let's do a little better with our simplifying this time. We now have z minus 9 is equal to 9x plus 6y minus 18. Let's get all our variables to one side and our constants to the other, so that our plane equation becomes 9x plus 6y minus z, and the negative 9 plus 18 is positive 9, so this would be our plane equation. So let's verify our answer in GeoGebra. So here we are in GeoGebra, and I've already put in our equations here. I just typed in z is equal to y squared times e to the x squared. In order to get an ordered triple into GeoGebra, we do need to use a capital letter, so I'm going to click this on, and you can see that that ordered triple is a point on the surface. And then I typed in the equation we got for our tangent plane, and it does appear that our plane equation is tangent to this surface at the ordered triple 0, 3, 9. It's a little bit easier to see from this top-down perspective.